You see, on R3, we don't have any redistribution from EIGRP to OSPF. As a result, we don't see any route on R10. When I try pinging 100.0.1.1, no ping. The reason is there is no type 4, type 5 allowed because there is no real ASBR. There is no real ASBR. What is ASBR? The router where the redistribution happens. We really don't have any redistribution. So there is no real ASBR, but R3 is the border to reach internet. EIGRP depicts internet for us. And there is a backup edge router. R3 is the edge router, and this is the backup edge router. And we run OSPF, we would like to inject default route so that all will go to R3 first. If R3 is unavailable, they will use the backup to reach EIGRP networks. That's the idea. Now I'm going to R3. In R3, I'm going to say default information defaults information originate. When you don't have a default route, you should use the keyword always. But I'm not giving always now. I'm not giving always. I just want to show you the impact. No always is given. So when I go now to R10 to verify whether I'm able to ping, I'm unable to ping. Do we have a default route now? No.
No.
OSPF will not inject default route. If we show IP OSPF database, this is type 3 and this is type 4, but there is no redistribution there. You know why this has come? This has come just now because I say default information originate. Even in the backup router, I'll say that, you see. Router OSPF 1, default information originate. Now you will see two router as type 4. It will come. You see? Two router as ASBR. Wherever you say default information originate, that is going to be considered as ASBR. Okay. Now, no type 5 because we don't have default route. See, I'm expecting a default route, but there is no default route. Why OSPF is not giving default route? Because we don't have a static default route. We don't have a static default route. Now, the reason why I do not want to have a static default route is I have route here to reach 100.0.1.1. I have a route. I'm running EIGRP from my edge router to ISP. Let's say R3 is the ISP. Because I'm running EIGRP, I don't need a default route, static default route, isn't it?
Right.
So I am not having any default route. I'm having precise route given by EIGRP. So I do not want to use the keyword. I do not want to use the static default route. If we don't have static default route, this command is not enough. Which command? Default information originate is not enough. We need to say always. So I'm going to use the keyword always also on R3. I'm going to say always on both router 3 and router backup. Now if you go to router 10, you will have a default route as type 5. Both guys are giving. Both the guys are giving the default route. But you do not want to use both. Listen carefully. Because it is EIGRP, you may be happy to use both because EIGRP can do unequal cost load balancing. If it can support unequal, it can also support equal cost. So, if you check the routing table, show IP route OSPF, you have a default route E2 pointing towards router 9. Router 9 will go to 8, 8 will go, and if you go to router 4, let's see router 4. Router 4 will have two default routes. So I route OSPF. Look at this. Router 4 has got two default routes and the cost is same.
Right.
So the load balancing will happen. But if you wish to have any one as a primary, the other one as the backup, what I need to do is I'll go to the backup route and I'll say cost. I'll say metric. And then I'll say 100. So now router 4 will not have two routes in the routing table because the cost is increased. Earlier when I checked, the cost was same, isn't it? Now
Yes.
this route will not be there. Let me show you. You see it's gone. In 33, dot 33 is gone. Earlier you had
Right.
dot 33 which was newly added. Now because of the cost, it is removed. But in the database you will have both. Show IP OSPF database. You will have both in the database.
Right.
So we have used the always keyword and we have used the metric.
Metric. Right.
Now if you say no, don't use the always keyword, there is a way. Let us remove this. Let's do the same thing without using always keyword. For that, I need to write default route. I need to write two default routes. One on the backup router, the other one on the primary.
R3.
So before that, let us try checking whether we see routes, the default route in R10. No, there is no default route. Let's check the database. There is no type 5. There is no type 5, only type 4. Type 4 is there because we have the command default information originate. The early command do show run section router OSPF. You see this command is still there. I
Right.
removed only the always command. So what I'm going to do is I'm going to have a static route IP route, any network, any subnet mask. Send the traffic to 10, 30, 22. That's on the backup route. And on the main AS, sorry, yeah, that's right. On the primary ASBR, I'm going to say 10. I'm not sure what subnet we have. And go to router 2 and check. We got 10, 23. Yeah, this one. So this is the one. 10, 30. All right. So now, because we got a static default route, you will see now the route on R10. Go to R10 and check for type 5 LSA. Here we go.
Yep.
We got type 5 LSA and check the routing table. Show IP route SPF. We got default route. Let's try pinging. Ping 100.6.1.1 and we are able to ping. Right, that's about the
Perfect.
default information originate, default information originate always, and then what this one metric using our own metrics.
Right. It's nice. That's
Now,
perfect.
thank you. Now let us do a stub and total step. Stub and total step. So I'm going to remove this default information originate and I'm going to do the redistribution. Okay.
Okay.
The reason is I want to teach stub. In stub, type 4, type 5 is important, right? So,
Yes.
so I'm going to remove this default information command, and also on R3, I'm going to remove that. Okay, as a result, now I should not see any type 4 and type 5. Not even type 4 should be seen. Show IPOSPF database, show IPOSPF database, summary. Oh no, there is no type 4. Okay, so let us do the redistribution. On ABR router, where are you? ABR. This is ABR. Let me change the name as ASBR. Okay. On the ASBR router, still it shows R3. It is okay. In ASBR router OSPF1, redistribute EIGRP10 with a metric. I'm going to say metric of 10 from this. Metric of 10. Whereas on the backup router, do we need a backup first step? Not necessary. Let's remove this. Okay, it's unnecessary. You need to increase the cost and redistribute. It's a waste. If you want, you can have. You want me to keep it? I'll keep it.
Yes, yes, yes. Keep it.
Router OSPF1, redistribute EIGRP10, metric 100. That's it. Now, what we are going to do, we're going to test it from router 10 again. Router 10, you should have now type 4 and type 4. Wonderful. Look at this. Oh, this coming through two gateways. Two gateways,
Right.
two gateways, two gateways. Type 5 is too big. Too big. Okay. Now we start the story of special area
Where
type.
are the type 4s?
Type 4 is there.
Let me see it.
Up here.
Okay, okay, okay.
Now type 4 originates from your AVR. Type 5 originates from the original router.
Right.
Now we are in router 10. Let us check the routing table. Let us check the routing table. Show IP route summary. Look at the size of the routing table. It is too big. Just consider as too big. In the real world, this is not that big, but in our scenario, yes, it is too big.
Right. Right, right.
12,000. And OSPF alone has taken around 5,000
Right.
routes. And in that, the EIGRP routes are 14 in number. 14 routes are coming from EIGRP,
Yeah, yeah.
external. Now, I do not want to have this 14 routes. I just want to have only one default route to reach this 14 destinations. You got it?
But I have a question before that.
Yes, please.
Can we suppress the routes from the backup and let the route from the original ABR only show in R10?
Yes, we can do. So on the primary router, we have done the redistribution. On the backup router, we removed the redistribution and we have put the default information originate always. As a result, you will have both the precise route coming from R3 and the default route given by that. Let's check the database. You see in the database, you have now the routes coming from both of them. This is one additional default route you got. But this 111 is both given by this and this. I think it's not removed properly. If we go remove it, it might have taken. No, still not removed. No, still not removed. Not removed. So there is the redistribution still in place. Show run section router. Yeah, OSPF. Yeah, this redistribution still not removed properly. Now you will see what you want to see once I remove this. Okay, so let's go to router 10. Now this is what you want to see. Still it's coming. This is what
Yes.
you want to see.
Yes.
Yeah.
Yes.
So it is suppressed. At the same time, if I shut down this port, R3, let's shut down the port. Okay, let's. I'm very sorry. Before shutting down, let's ping this. Repeat. 1000. It's pinging. Now I'm going to shut down that port, and I'm going to repeat the ping for 5,000 times, and I'll go and shut down R3. Interface Ethernet 0/1, shut down. Now I'm expecting the failover. Using the default route, the ping should start going. It will take some time. The convergence should happen. The ARP should be learned. The MAC address should be learned. But this will happen. It will work. It should not take this long. Let me go and check an R4. Going on still not? Show IP route. Okay, I got a default route and it should send the packet here. The route is available. The route is available. But for some reason, what is it? I want to stop this thing and start the thing once again. Jeez. 1 minute, please. It's going to start the thing. So stop it. Control six. No. I'm able to stop this. Okay, let me bring the interface up. R3. I brought the interface up. So I want to stop this ping. $5,000 is too big. I did not expect because this virtual link is not going down. Though I shut down the. Okay, and now as we spoke, we are going to shut down this port. After shutting down, let me take you to R10. I should see a default route on R10. Show IP route OSPF. I still have the root default route to reach this network. Default route to reach this network. How is this coming? Okay, I think there is something more on R2. Show one section router. Show IP, show IP OSPF database. I should see a default route. Actually, the link is shut down. I don't know why this is shown again. This should disappear. It will take some time. Uh, but in the routing table, you got only this. This is more than enough. Let us test it. 100.1.1.1. Come on. This fallback is not happening. Actually, the fallback will happen according to the control plane. This is the one which it is going to use. No doubt. You go to router 9, and router 9 will send to router 8, will send to 4, and even if you C4, show IP router OSPF, it's going to send it to only this router 33. Let's try pinging from here. Ping 100 dot. See, router 4 has got had two gateway, but now one is down, the other one is back up alive. Let's see. See, it's the problem with this virtual environment here. The routing table is very clear, you see. This is not the problem with OSPF, this is the problem with the virtual environment. The routing table is very clear. You need to send the packet here. So it is because of that, otherwise this will happen, this will work. Let us bring R3 back. So we are going to another stub concepts. In the real world, this failover will definitely work. Okay. So router 10. Now if you try ping, the ping should happen. And now in the database, this is what you wish to see, and you are seeing it.
Right.
Okay. Now if I make this area as a stub area, what will happen? The type 4 and type 5 will be removed. Instead, you will have one additional type 3 default route. So this will become 11. Type 3 is what? Inter area, isn't it?
Right.
Is it inter area or intra area?
Is it?
Yes, inter area, between areas. This will become 11.
Right.
This will become 11 because type 3 is going to be one additional default route, and this will become 0, and this size will become smaller. At least, it will come down to 10,000. Let's see that. So for that, I need to start from router 8. Starting from router 8. On router 8, show IP, no need. You need to say router OSPF 1, area 20 is a stub. Please understand, when you configure stub, there will be a flag in the hello packets on. I'll capture in one in Wireshark, and I'll show you in the other day. I don't have Wireshark right now with this EVE, but with GNS3 I can show you. So that flag should match in order to have neighbor. What I'm trying to say is, in area 20, if you make this as a stub, this also should be configured as a stub, and this also should be configured as a stub. Otherwise, the neighbor will not come. You see, as soon as I hit enter, you lose the neighbor with router 9. Look at this. Router 9 is down. And when you go to router 9 and configure stub, router OSPF 1, area 20 is a stub. After you say this, you see the neighbor has come up back, but it has lost the
Right.
neighborship with router 10.
10.
So I'm going to router 10 and I'll say router OSPF 1 area 20 is a stub. Now the neighborship will come back. All right. Now let us check the routing table. Show IP route summary. Look at this. It has gone less than 10,000. As I said, this is 0 and this is increased 1. You know which one? Show
Right.
IP OSPF database. This is the one.
Right.
There is no type 4 and type 5. Show IP route OSPF. You see, you got a default route. With this default route, you will be able to ping 100.4.1.1. You see, you're still pinging even though there is no route available. Yep.
Yep.
All right. So this is stub. When you say totally stub, even type 3 will not come in. It will use the same default route to ping. You understood?
Yes.
Even this type 3 will not come. Only one type 3 will be there. All other type 3 will be removed. Which means
Right.
when you type summary, in the database you will see only this line, none of this line after I configure totally stub. And when I say summary, this will be only 1. And now think about the size of the routing table. Earlier it was 11,000 plus. It will go even to 5,000. Yeah, let's go and check. But for the totally stub, the only place you need to change is here. You simply say
Right.
summary keyword. No
Right.
summary. And the stub that you configured earlier on 9 and 10 should not be removed. It should be there. Let's
Right.
now go and verify and router 10. Router 10, where are you? Here we go. You see the size has gone almost to 6,000. And then
Right.
there is only one inter area, means type 3 is only one. And which one is that? This is that one. And if you check
Right.
the routing table is also very small. You see, more than a
Yes.
summarization, stub is good. You can still ping 4.4.4.4, which is in area 10. You can still ping 1.1.1.1, which is in ASBR. You can ping 100.6.1.1, which is in ASBR.
Right.
Right?